Hey there, welcome to another episode of the BlockCrunch podcast, where we share condensed insights from builders and investors in the world of crypto and blockchain. I'm your host, Jason Choi. And this episode is a continuation of our discussion with Lane Rettig, core developer from Ethereum, regarding the two biggest challenges facing Ethereum today. One being governance, which we described and discussed in the last episode, and two being scalability, which we will discuss in this episode. So if you haven't checked out the last part, definitely go back and check out that episode first before coming here. And otherwise, if you're ready, then let's buckle up and dive right in.
This is this worldwide phenomenon.
Let's shift gears to focus on scaling a bit, because you mentioned before that there are two dimensions when it comes to scaling, when it comes to Ethereum. There's a technological dimension and there's also a social dimension. So I wanted to dive deeper into the tech side later, but first, can you explain just from a 30,000 foot level, what's the difference between the tech dimension and the social dimension when it comes to scaling?
Excellent question. And I'm really happy that you sort of highlighted this fact that there's these two dimensions of scaling. I feel that, so again, for reasons I described before, right, the sort of movers and shakers in Ethereum up to and including the present primarily are technologically focused, right? For that reason, the technological side of scaling in Ethereum has gotten a lot of love, a lot of attention, a lot of money, a lot of press, et cetera. There's a lot of great minds and great teams working on it. The social side is very, very different. And I think that side can be quite uncomfortable, unfamiliar, and maybe even a bit scary to the sort of engineering mind that's very common in Ethereum today. I would say the two really don't have anything in common except for the fact that, that they're both about scaling Ethereum, right? So getting it to the next level. In the case of the technology, that means, it's multidimensional, but the simplest way of looking at it is things like transactions per second or transaction costs, right? Can we go from kind of the 6 to 10 to 12 transactions per second that we're at right now, 15 sort of maximum, to, many hundreds or thousands or tens of thousands of them? The social side is a completely different question. It's, can we turn Ethereum into a platform? Can we build it? Can we evolve it into a platform for not 1,000 or 10,000 nerdy engineers, but for millions and ideally billions of human beings to use and transact, right? Flat out, that's the question. It's very much an unanswered question. Part of this, I would actually say that technological scalability is definitely a requirement for social scalability, right? There's no way we can have 1 billion people transacting on Ethereum if the technology is not there and if transaction costs get huge. But it goes far, far, far beyond that to, I don't know, again, multidimensional, lots of angles here, but things like education, things like user experience, usability, things like fairness, justice, those sorts of topics.
Mm-hmm. And when it comes to social scaling, that probably will be another topic in and of itself. And I think you recommended Nick Szabo's blog post on this, which I recommend for my listeners as well. But let's focus more on the tech side of that right now. And I know you mentioned before that when it comes to technical scaling, there's almost always a trade-off between decentralization, scalability, and safety. So why must there be these trade-offs?
That's a great question. Yeah. So there's this sort of fundamental trilemma, which you're touching upon. And, the blockchain space, I guess the world, right, is sort of full of dilemmas and trade-offs. And I think the fundamental, there's some sort of technical name for this trilemma, but basically it's sort of, if you imagine a three-pointed triangle, right? We have scalability, we have and scalability here is defined as something like throughput or transactions per second. We have decentralization, which is the second axis or spoke, and we have safety or security, right? So decentralization is basically the number of block producers, the number of nodes that are authorized to produce blocks and contribute to the sort of consensus safety of the network. And security is basically the cost of mounting an attack against the network. And your question is, why does this exist? It's sort of down to physics. Wow, I have to take a second here to think if I can explain this. It's a series of trade-offs, right? So if you increase the number of blocks, let's start with that. The number of nodes, the number of block producers. The more of them you have, the more overhead there is around the sort of number of messages that they need to communicate with one another to achieve consensus. And for that reason, as the number of block producers goes up, the scalability of the network goes down. There's a really great blog post here by Vitalik on this topic from a few years back, talking about how Ethereum arrived at its sort of 12-second block time. And it's really an interesting kind of breaking down this trilemma and things like it, and actually relating it to simple equations in physics, something along the lines of time traveled times speed of travel equals distance traveled. And I actually believe that you can map that. There's sort of an isomorphism between basic physical principles and some of these trilemmas, like the one we're discussing, which is why they can't be violated. And so what you see with the sophisticated technological scaling initiatives, so things like sharding in the case of Ethereum, and I believe Dfinity, there's a couple of other ones. What they've tried to do is they sort of square the circle, or I guess you could say kind of square the triangle, right? So they kind of find some point of compromise where you're giving up a little bit of each of them, but hopefully finding a sweet spot, kind of what do they call that? Kind of the Goldilocks point.
Mm-hmm. And it's funny that you brought up sharding, because that's actually going to might be my next question as well. We are seeing so many different solutions that are proposed for scaling that are kind of traversing this trilemma. So I'd like to maybe start focusing on the so-called layer one scaling solutions first, just to map out what type of scaling solutions there are out there for our listeners. So for layer one solutions, there are, to my understanding, sharding and also Casper, which itself is not a scaling solution, but allows scaling solutions to be built on top of it. And you personally are working on eWASM, like you mentioned, which is an environment that would allow sharding to be run, among other things. So just very briefly, can you explain maybe what sharding is? How does it work? Who's leading the efforts? And what is the status quo right now?
Definitely. So sharding is as you described, it's a layer one scaling solution. It is kind of the marquee, or kind of the vanguard scaling solution in Ethereum. So it's kind of like, it's a little bit of an exaggeration to call it the scaling solutions to, the scaling solution to solve all scaling forever. It's really not that simple, right? There's a lot of, one thing you'll see about scaling solutions when you zoom out is that there's a lot of complementarity among them. So for example, Plasma is more or less completely orthogonal to sharding, but they actually work really well together, and you can kind of have Plasma chains running in shards, and even vice versa in some scenarios. So sharding attacks this fundamental starting point in the scalability challenge, right? And that is simply the fact that today in Ethereum and in Bitcoin and many other networks, every node in the network needs to see and process every transaction, flat out. That's the way the system works today. That's the way it was built, and that's intentional, right? That's how we guarantee security. If a full node weren't seeing all transactions, then there'd be no way for the full node to verify in a self-sovereign fashion that the network was completely secure. There's no double spends going on, et cetera. The problem is, of course, that doesn't scale, and it means that Ethereum is only as fast as the slowest node, really. And so sharding is an attempt to fix this from the base layer by breaking up all the transactions, all the accounts, into some number of shards. So this could be something like 50 or 100, or actually the sharding kind of works quadratically as well. You can you can actually have shards inside of shards, assuming it works, and so it kind of, in theory, scales infinitely. But I believe the plan is to begin with something like 50 to 100 shards, and then each node, if you do the math, right, only needs to see obviously a subset of the transactions in the network. Now, that sounds all well and good. And sharding in this respect is a concept that's very well understood from the database world. Large databases have been sharded for decades, but the problem arises from, again, the security question, right? It's in sort of the Twitter and Facebook world. It's not the end of the world if a tweet gets posted twice, or appears in one place, and only maybe you have eventual consistency, right? You sort of need these strong security guarantees in Ethereum, so that if Bob has 5 Ether in his account and sends 3 Ether to Alice, then he can't then send another 3 Ether to someone else, more or less, all at the same time. So again, the challenge here comes around coordinating, tying together the security of all the shards.
And that's amazing because you actually answered my second question, which is, are there any systematic risks that comes from sharding? So I guess we can move on to the next kind of solution, which is Casper, which refers to Ethereum's specific implementation of proof of stake, or for our less technical listeners, essentially a new way of processing transactions on the Ethereum blockchain that is less resource intensive than the current solution. And my understanding is that there are two research projects proposed to implement this on Ethereum right now. There's the CBC camp proposed by Vlad Zemfir, and there's also the FFG camp proposed by Vitalik Buterin. So can you maybe explain how these two fit together? Are they mutually exclusive? Does one come before the other?
Yeah, excellent question. So as you said before, right, Casper, which is Ethereum's proof of stake workstream, is not in and of itself a scaling solution, but it's a vital component of the overall scaling initiative, and it enables other things such as sharding. There are two work streams, Casper FFG and Casper CBC, as you described. And I think you used the word camp. Camp is a little bit strong, just because well, the reason is because it sort of suggests mutual exclusion. It suggests that you kind of have to like pick a camp or pick a side. It's sort of just two approaches, and they're very, very different, although they do share quite a bit. And last I heard, the long-term goal was to merge the two work streams, but a lot is up in the air right now, and I am not actively working on Casper, so I actually don't sort of know the absolute most up-to-date roadmap. What I can say about the roadmap, of course, is that now, about a month ago, there was a pretty big announcement, which was that previously the Casper and the sharding initiatives had been more or less separate. And in particular, the plan, there was sort of this minimum viable sharding plan that was released, and there was an EIP that was more or less, I guess finalized is a strong word, but it was in a pretty mature state, and many teams working on implementing it. And there was also very, very close to being a working first proof of concept of Casper FFG. And the decision was made that actually, hey, let's not rush into this. I think, this is not me. This is kind of driven by the research team, but the decision was made that it would be better if those two initiatives were kind of merged into a single work stream, which I'm referring to as Casper, because it's sharding plus Casper. I still haven't answered your question. So the difference between the kind of CBC and the FFG Casper. FFG stands for Fast Finality Gadget, and it's an overlay on top of proof of work. So what that means is that the blocks are proposed the way that they're proposed today. So you still have miners running a proof of work algorithm, still burning that electricity to propose blocks and still winning sort of that computational race. But then we have this sort of elegant overlay gadget, right? Again, that's where the word gadget comes from, which sits on top of that process and provides something called finality. So the really important thing to note, distinction here between proof of work and proof of stake, is that in proof of work systems, including Bitcoin and Ethereum today, there is no explicit finality. We have what's called probabilistic finality. And that means that a block that has other blocks that have been built on top of it, right? We sort of wait a certain period of time, right? That's why we typically tell people to wait something in the order of 3 to 6 blocks in the Bitcoin world, or maybe kind of 10 to 15 blocks in the Ethereum world before we can call a transaction which sits inside a block basically finalized. And it's a probabilistic thing. We're saying that the likelihood that there's a longer chain out there that hasn't been discovered yet, the likelihood that we have a reorganization of the chain at this point is infinitesimally small. Well, with proof of stake systems, with Casper, we get this very nice property that we have what's called explicit finality, which means that once a certain number of the validators have voted in a certain way on a certain block in the chain, that block can never be reverted. And that is the property of proof of stake and of Casper, which enables things like sharding. And the difference here with the CBC Casper is that it completely replaces the existing consensus mechanism, the existing proof of work consensus mechanism. CBC stands for correct by construction. So it's an algorithm which is designed from the ground up in a very elegant way to be correct by construction. That's Vlad's project.
Got it. And in the interest of time, I'd like to also touch briefly on layer two scaling solutions as well, in particular, plasma side chains. So briefly, can you maybe explain what plasma is and what is its status quo? How far are we from seeing plasma from being implemented?
Definitely. I want to preface this by saying, and probably should have said this earlier, I'm in by no means an expert on Plasma or many of these other scaling initiatives. So I'll do my best to answer your questions and maybe try to kind of point people at other resources where possible. Plasma is a sidechain initiative, as you described. It is, I'd also call Plasma a family at this point. It's funny, we refer to Casper as a family of technologies or of protocols because we have those two work streams that we just described. There's now, as with Casper, there's now several different kind of ideas around Plasma. There's something called Plasma Cache, and I believe there's a couple of, at least one or two others that have been proposed recently. It's a sidechain implementation that has a really nice property, which is that all the transactions on the side chain are checkpointed back to the main chain every so often, every n blocks. And for this reason, it means that participants in a Plasma chain can always fall back on the main chain. So I'm assuming here that we're talking about a single Plasma chain running on top of the Ethereum main chain. But as with sharding, et cetera, this can be done quadratically. And so you can actually have Plasma chains inside of Plasma chains, right? So you're sort of, you have the ability to appeal back to a lower level of security. And in the case of malicious behavior on the part of the operator of the sidechain, you as a participant in that chain, as long as you're watching the behavior of what's going on in that chain, you can then appeal back to the main chain, which would mean submitting something like a fraud proof to a smart contract on Ethereum, and you would then be able to exit that chain in a trustless fashion, and you wouldn't lose any of the tokens that you had moved over to the Plasma chain. So that is this kind of unique property of Plasma side chains, this guaranteed trustless ability to exit at any time.
And how far are we from seeing the actual implementation of this?
So I'm not doing implementation of Plasma myself. There is something called a Plasma implementers call, which happens something like every 2 weeks, and those calls are recorded and publicly available on YouTube. I've seen several of them. They're really great. Last I've heard through the grapevine, there's a number of teams such as Omisego that are working on this. They have multiple people working full-time on it. I guess you hear this a lot in Ethereum. It's pretty close. I do think we'll see the first Plasma chains launch in production main chain in 2018.
2018, got it. And the reason why I wanted to walk through all of these scaling solutions is to ask this question, basically pulling this to a very high level from the perspective of a developer in terms of prioritization. How would you rank the initiatives in order of urgency and how achievable they are? And are they all needed?
It's a great question. When you say urgency, you mean just sort of from the perspective of the Ethereum protocol or kind of the entire ecosystem, not from the perspective of one particular person or application?
Yeah, from the perspective, I guess, which one of these initiatives is Ethereum, are the developers in Ethereum prioritizing more, if they are prioritizing any of them in particular at all?
Yeah, I don't think there's a simple answer to that either. I think that there's a couple things to point out, right? The first is that each of these initiatives is being led by a different group of people with different sort of incentivization. So sharding, which we spoke about alongside Casper, is definitely the main project being pushed forward within the Ethereum Foundation. But the Ethereum Foundation is not the entire ecosystem, and there's many other teams working on many other exciting scaling initiatives, including several we didn't get a chance to talk about, like Cosmos, Polkadot, right, which are these kind of interchain networks, as well as things like state channels. And generalized state channels, which are very exciting. I really think that the different teams are prioritizing different solutions because they have different applications. As with most things in sort of technology, engineering, computer science, there is no single master technology which solves every problem for every potential application.
And are they kind of mutually exclusive?
Yeah, I touched upon this before. No, not at all. On the contrary, they're extremely complementary. And I don't think it would be at all surprising to see an application which, runs in a state channel, which is tied to a Plasma chain, which lives inside a shard. Like, I think if you fast forward 2 or 3 years, all of these things will absolutely be working together. I think the most important point to make here is there are 4 or 5 or 6 or 7 independent, serious scaling initiatives underway right now. I think many of these will begin to go to production this year, and we do not need all of them. right? Each one of these gives us at least one, actually probably more like 2 or 3 orders of magnitude increase in things like transactions per second. And the multiplier effect is very powerful, right? Once you start having these quadratic, X inside of Y effects. But even if we only get 1 or 2 of these things in production this year, I think that will go a very, very, very long way to scaling Ethereum.
And for listeners who want to have a overview of all of these scaling initiatives being planned and discussed and developed by Ethereum right now, Lane actually did a talk on this where you prepared a really interesting taxonomy for these different scaling solutions. And I think it was in Buenos Aires. Is that right?
That's right. That was at ETH Buenos Aires about a month ago. I'm sure you could find the video on YouTube.
Yes, I highly recommend that to my listeners. And just to close off this interview, I know you've spoken very briefly about something you're working on called the Odin Protocol, which could be another episode in and of itself. But just very briefly, what is that, and what are other things that you're excited to be working on in the future for Ethereum and beyond?
It's good timing to ask this question. I definitely have sort of side interests and side projects, as we mentioned before, and I was just, as I said, sort of yesterday trying to compile a list of them, and it was a bit terrifying. I think I need to focus more. Odin. So the name Odin comes from an acronym ODI, which stands for Open Data Initiative, and that particular kind of idea came out of conversations I had, funnily enough, with Richard Burton. I know that you spoke to him just yesterday, so he may have touched upon some of this. But as you know, he is running a company called Balance, which is building a wallet, and was really struggling with pulling some of the most basic data out of the Ethereum blockchain, things like ERC20 token balances. And he's relying very heavily upon a very small number of centralized providers, people like Etherscan, to provide this data. They don't have service level agreements. And I guess just sort of inspired by that conversation, I began doing some research on this, and I was kind of shocked to really understand how difficult it is for teams that want to pull this sort of data, which should be relatively straightforward to access via some, dead simple API like in the Web 2 world, right? How difficult it is to pull that data out of Ethereum today, because among other things, they need to run their own full archival nodes, which is extraordinarily burdensome. So I kind of began pitching this idea of building a basic protocol around this so that someone could fire up a sort of additional piece of software running on top of a full node, and it would do the extraction, the transforming, the loading of that data, and then offer it up to the network in a trustless fashion, and they could then be compensated for offering that data. I wouldn't call it a project on my part. It's more of let's call it an avenue of inquiry. But I found one team in particular that is working on this problem in a very compelling way. And I won't share more about that at this moment, but I expect to be sharing a lot more about that project very soon. So I'm very excited about it. Other stuff, I would say the social scalability piece is probably the thing aside from EOSM that I'm the most excited about right now. It's kind of my other biggest avenue of personal inquiry, I guess you could call it. It's sort of a research pet project, particularly things like wealth distribution. I want to understand, we have very limited data about this today. So what is sort of the wealth distribution in Ethereum? How does that stack up to other blockchains? And what lessons are there for token design, mechanism design, token economics? Can we do better? What does it mean for side chains? Those sorts of questions. And basically, how do we get Ethereum to a place where we can realistically get 1 billion people onto it and have room for all those people?
And that's a lot of exciting stuff coming from you. So for listeners who want to keep up to date about what you're working on and see more of your thoughts, where can they find you?
Twitter is the best channel. So I'm L Rettig, that's LRETTIG on Twitter. Not a huge social media user, but I make an exception for Twitter. And I really hope to be sharing a lot more thoughts in the form of writing, mostly on Medium, and hopefully audio, maybe some kind of sort of a podcast thing and or video in the near future. So I'd love to hear feedback from people, and Jason, from you as well, on which of these topics sound interesting and what's the right format to get them to the widest audience possible.
Yeah, of course. And super excited to keep up to date about what you're working on. So thanks for coming on the show.
Thanks for having me, Jason. This has been a great conversation.
And that wraps up the second part of our discussion with Lane with regards to the biggest challenges facing Ethereum. In the next episode, we will be talking to Jill Carlson about big challenges facing token projects, in particular, projects that have raised their own ICOs. So I'm incredibly excited to share more with you. And if you'd like to stay up to date, definitely subscribe to this podcast and give us a 5-star rating so we can get this out to as many people as possible. You can also follow me on Twitter at Mr. Jason Choi. That's MrJasonChoi, where I will be sharing all of our episodes as well as transcriptions for some of our interviews. With that being said, I have been your host, Jason Choi, and this has been the BlockCrunch Podcast.